Okay, in this video, let's discuss about how to finding a scalar product of a given two vectors, right? So as we already learned all the definition, let's say if I have a vector A, I given this to be x1, x1i plus with y1j plus with z1k, and vector B to be x2i plus with y2j plus with z2k, right? Let's say this is a given value, right? So now we put it as unknown in algebra form. So I'm going to prove to you that how to doing a scalar product. And okay, before we doing a scalar product, we should understand the process of getting that scalar product. So we know that A dot B, the meaning of A dot B is I taking the vector x1i plus with y1j plus with z1k, the whole thing to be dot with the vectors x2i plus with y2j plus with z2k, right? So I'm going to do the dot product in a long process, and finally I will generate a formula for finding the dot product. So as we're doing dot product, we know that so we are doing one by one. So x1 with x2, right, is a number. We multiply the numbers as x1 and x2 is a number, and i1 dot with i1 we go and dot with, as this is a vector, so we dot the vector. So we only do dot the vector. So, and this is a number, we just multiply, right? It's a scalar. So, and followed by x1, right? x1 with y2. X1 with y2. So we just multiply the number, and the vector, we dot the vector, right? So it will be I dot with j, right? From this with this, right? Now this with this. So you have x1 z2, alright? x1 z2, which is I dot with k, right? I dot with k. Alright, you have to be patient and plus, right? Keep adding. Now this is already with all the term here. Now followed by this one, y1 x2. This is a long-winded derivation. x2, which is j with I, right? J with I, and followed by y1, y2, right? y1, y2. J dot j, j dot j, and followed by y1 z2, y1 z2, j dot with vector j dot with vector k, j dot with k. Alright, now done with the second. Now the third one, plus with z1 x2, right, which is k dot with I, right? K dot with I. Now this and this will be z1 y2, z1 y2, z1 y2, k dot with j, right? K dot with j. Then lastly, z1 z2, z1 z2, k dot with k. Alright, then I have done all the expansion, okay, of by using dot product. But we have to understand something before we doing this, okay? Means that you have know that I dot I, what is the result? And j dot j, what is the result? And k dot k, what is the result? All the important result here have to be referred to the axis, alright? You have x, y, z axis, right? X, Y, Z axis. As you know that I is the unit vector for x axis, and the unit vector for y axis is j, and the unit vector for z axis it will be k, right? And each axis is perpendicular to another two axes, right? For example, x axis is perpendicular to z and also j, right? And y is perpendicular to z and x. They are perpendicular to each other. So follow the definition of A dot B. This is the most basic definition. which is magnitude of A, magnitude of B, cosine theta, right? So if the two vectors are parallel means, for example, or in this case special is identical, right? What happens if both is identical? Now I explain what is happen if both is identical. Vector A, vector B, cos. So sorry, the vector B become A, right? Identical. So the angle between the two identical two vectors, right, which is identical, is coincide in the same line, right? Coincide. Okay. So the angle between them will be 0 degree, right? Cos 0 will giving you magnitude of A, A1, right? Which is magnitude of A square. This is a very important result. So means that I dot I is a magnitude of I square. So A dot A is a magnitude of A square. So J dot J is a magnitude of J square, and K dot K will be magnitude of K square. What is magnitude? How to find the magnitude of I? So there are many knowledge that you should know, right? It's the square root of 1 square plus with 0 square plus with 0 square. Because I refer to I plus 0j plus with 0k, as the magnitude will be giving you 1. The same also for magnitude of j, magnitude of k, all were giving you 1. Because why? This is all is a unit vector. So you're getting 1. 1 square, you're getting 1. 1. 1. Very easy. So as a student, I just memorize. I dot I is 1. J dot J is 1. K dot K is 1. So it's to easy the way for us, right? So as a knowledge, this is the process. Alright? And how about I dot J and J dot K, right? Alright, how about those, let's say, okay, before that we have to discuss with this. Let's say A dot B is equals to magnitude of A, magnitude of B, cosine theta, right? Yes or not? So we know that A dot B is the magnitude of A, magnitude of B, cos theta. So, and if A is perpendicular to B, right? From the first video, I talked about definition of scalar product. So if perpendicular, the A dot B will be equals to 0. As you know that vector I and vector K, the angle between them is 90 degrees because they are perpendicular. J and K are perpendicular. J and I are perpendicular. Alright, so A dot B will be 0. Alright, so to be said that this cos 90 is 0, right? So means that what I can conclude about is I is perpendicular to J, and they are perpendicular to each other. So means when I said I dot J, it will giving you 0, or J dot I, they will also giving you 0, because J and I are perpendicular to each other, right? And also the same, if I take I dot with K, x-axis and z-axis is actually perpendicular to each other, and z is also perpendicular. So A dot B is equals to B dot A, right? And another one will be J dot K is also 0. K dot J is also 0. As long as these two vectors are perpendicular to each other, they are 0, right? So, okay, why I'm talking about this? First, if there are two identical vectors, if when you dot, you're getting 1. I have already tell you the reason. So if they are two perpendicular vectors, for example, I and J, J and K, K and I, they were giving you 0. So now, okay, you have this knowledge. Now look at this thing. How to simplify, right? How to simplify? I can tell you that this I dot J will turn out to be 0. This also will be 0. I dot K is 0. Alright. J dot I is also 0. K dot J, K is 0. K dot J 0. And K dot I will be 0, right? Okay, then now this will be 1, right? This whole thing will become 1, and this will become 1, and this will become a value of 1. All right? Okay, now let's see. I'm going to show you what is the simplified form. All right. From all the results just now that I cancel out, there is some 0, some is turned to be 1. You can see that there is x1, x2 to be 1, right? I dot I. Okay, you can check back. y1, y2 to be j dot j, which is 1, and z1, z2, k dot k, which is 1, right? So as a result, you can see that this is actually x1 multiplied with x2, x1 multiplied with x2, a simplified form, the shortcut, right? That you're not going to go through everything one by one, right? So the short form here will be, the short way will be, you're just taking x1 dot with x2, multiply, plus with y1 multiply with y2, right? Plus with z1 multiply with z2. That's all. It's a lot simple, right? But how to get such simple thing is because from the hard work behind this derivation, right? You have to understand this. So, or very simple. You can see that if a dot b, you can write in this form. You can write in its form x1, y1, z1 in column vector form. So then you have x2, y2, z2, right? So you just multiply x1 multiply x2. It's a lot easier after the derivation, right? Later you just apply this method and finding the scalar product, y1 multiply with y2 and add up z1 with z2. That's all, right? So now you know what's the reason why you can multiply and just add up, right? Because of the hard work that you're doing now, just now. Alright, okay. So later on, I'm going to show you how to multiply, right? By using two vectors, the multiplicator two vector by using scalar product. Right? So see you in the next video.